Today, I want to talk to you about pasta. Have you ever wondered why pasta comes in so many different shapes if it's all made from the same ingredients? Well, my grandmother is Italian, and she used to tell me that each pasta shape is perfect for a certain sauce and its ingredients. In my PhD, I work with carbon nanomaterials. They are smaller than 100 nanometers in at least one dimension, and just like pasta, they can come in many different shapes, but they're all made from the same thing, carbon. They are fascinating because they show properties that we do not see in macro-scale carbon. And these properties are particularly interesting for water treatment, especially because these materials can remove contaminants that conventional treatment plants cannot remove very easily. However, even after decades of research on nanomaterials, we still haven't reached real-world applications. One of the reasons is that we still know very little about the mechanisms that explain how these materials behave in real complex wastewaters. This is very different from what we know about pasta. Over hundreds of years, people have learned how to match each pasta shape with its perfect sauce. We know, for example, how the long, smooth strands of spaghetti are perfect for light tomato sauce, or how fusilli spirals are perfect for trapping thicker sauces. In a similar way, contaminants like microplastics or petroleum derivatives present in water can be trapped or even degraded depending on the size, shape, and surface chemistry of the nanomaterial. However, in nanotechnology, we don't have this rule book of interactions the same way we have for pasta. That's why my research focuses on establishing a linking connection between contaminant types and nanomaterials composition. I do that by making small variations in nanomaterials and applying them into complex solutions to test their efficiency with several interfering substances. By doing that, we can decipher the mechanisms, understand how these interactions work, and determine at the molecular level the right shape, properties, and surface chemistry to the contaminant we want to remove from water. Just like that, instead of just guessing which nanomaterial might work, we can design the right process from the beginning and take these wonderful materials outside of research papers and take them straight to wastewater treatment plants. Carbon nanomaterials are like pasta. Contaminants are the sauce. All we need now is the right recipe. So let's start cooking.